Katerina. Windows activate. Windows काय तुझं? Oh, sir.
Cái là mà vô này rồi nó ta.
Ubuntu all.
Apps khasa yani open browser the participants na job analyzing
Hello everyone, good morning. I hope everyone can hear me. Okay. So today our plan is to talk about few theoretical parts in different cryptographical applications, like how you do the SSH or how you do HTTPS kind of stuff. And then I will try to go quickly through a few hands-on in securing few of the services. And then I will discuss something on IDS, IDS, IPS general. And I might try to, if we have time, I might try to even go through some slides on Snort, because we consider Snort as one of the capable IDS systems in the open source arena. So it's free for use, so you can have that. Yeah, so that's the plan for today. So I'll start my presentation. Okay, so these slides are about the cryptographical applications and how you can use these sort of applications in different ways and the theories behind that. So if you have done any security related learning or training somewhere, then most probably you might have seen these basics. So for some of you, it might not be a new thing. But for some of you, it might be a new thing. But basically, this will be the background of most of the applications that runs cryptography. So yeah, let's see how it goes. But so hope everyone will stay with me throughout these slides. And again, today, this will be like a lot of text, but today we have few images, not like yesterday. So yeah, let's see how it goes. So again, welcome everyone and good morning. So we will continue with the cryptography basics and applications. So when we talk about cryptography, what is cryptography means? You try to hide something for others in a communications channel. So in the basic idea, what cryptography does is it will encrypt your data and with some sort of a key. So it will hide whatever the content, the actual content from the others, or the plain text content will be changed into an unreadable format for others. So that is what it does. So there are a few words like cryptanalysis and cryptography. So cryptanalysis is kind of analyzing the applied cryptographical mechanism and maybe trying to break the code. So that is also there. So basically, we use these kind of functions to show that there is kind of a cryptographical application running. So in this case, it's like C is the output of whatever the function. So the unreadable format, human unreadable format will be just the C, or what we call here as ciphertext. And the function can be any function. So today there are a lot of cryptographical functions which we see in the internet. So there can be a lot of functions for that. And basically almost every cryptographical function will have two inputs, that is the plaintext input and then the key. So they might have different other inputs, but you can categorize them into two things, that is the plaintext part and the key part. So that key part can be in different variables, maybe multiple variables. There can be multiple keys likewise. Okay, so this is the basic of cryptography, and let's see how it goes. Then where we use cryptography. So most of the time people think cryptography is only used in messages, to encrypt messages. So in this case, messages means something sending from one place to the other place. So from one source to another destination. So but cryptography can be used in different other purposes. So for example, if you may using digital signatures, then you are already using cryptographical applications. So we will talk about digital signatures later. And then if you are using different communications, encrypted communications like Tor network, then they use cryptographical stuff. So even the VPNs, they do the same. Then things like digital cache, they use the cryptographical applications to hide the identity, to be anonymous. So digital cache is another example. And then there can be different other applications like elections and private auctions, where they do the automatic winner finding based on different individual votes, but these votes are again unknown, or the anonymous votes. So they will be these winner finding will be based on the anonymity. So that is also there. Okay, I just disabled the waiting room of the Zoom meeting because there were like a lot of requests coming from participants. Hope no one else will get connected. Let's see what happens. Okay, so when talking about these cryptographical applications, some of the historical things we see is Even at the time of Julius Caesar, there have been different cryptography applied in their communication. So it wasn't computer communication, but or the electronic communication, but this was used the ciphering or changing the content into something that is unreadable for others have been applied even at that time. So the first thing that was on the record regarding the ciphertexting or using ciphers were the Caesar cipher or the ciphering method they used at that time. So what they did was they changed the alphabet by succeeding it into the third character. For example, if the actual alphabet starts with A, then the cipher alphabet started with C. So every character changed by 3 characters succeeding. So that was that Caesar ciphering. So even small days we try to do similar things when we were playing with different ages. So that was kind of the first applications of ciphering, and then after that there were several other ciphering methods like Vinegar Cipher, which was in the 14th to 15th century. And then around 1880s, there was a law defined saying the system, whatever the system that you are using for ciphering should not be a secret, but that means if even the ciphering system falls into the hands of the enemy, it shouldn't allow them to decipher or decrypt the messages. So the whole thing depended on the secret keys of the system. So that was called the Kirchhoff law. And then, so simply what it says is, whatever the function you use for the ciphering can be public, but the secret keys should be actually a secret, or you need to protect the secrecy of the key. So the whole message, the whole secrecy of the message depended on the key. So that is, even today, that will be valid for most of the applications, most of the mechanisms we use for different ciphering applications. So okay, so let's see. So the modern cryptographical applications, mostly they try to do the mathematical transformations, because we are now into the electronic transformations. So these encryption and decryption will be based on different mathematical functions, but still keeping the same previous main function valid. So there will be a function which gets the input as the plain key, plain text, and then the whatever the keys. Then most of the time these cryptographical functions, we now call them cryptographical algorithms or crypto algorithms. They are mostly not proprietary. So these cryptographical algorithms can be very much popular algorithms. So everyone know what that is. Why we use such algorithm is, if there is, so when something is public, when something is popular, there will be a big community behind that analyzing the same algorithm, whether checking whether it does what it should do. So if there is some sort of a weakness in this kind of algorithms, then definitely that community will find out whether this is usable or not. So that is why we use mostly the common or known algorithms. But there are some devices, some proprietary devices where they use their own proprietary algorithms. For example, if you look at some networking devices, some proprietary networking devices might have their own proprietary algorithms where they do different cryptography, especially for things like IPsec or VPN creations, password hashing, those things sometimes might have their own proprietary algorithms as well. But in general, most of the common applications, they will be using these common cryptographical algorithms. And then these algorithms are explicitly designed for encryption. So they are not for something else. They are specifically for encryption. So if you use some algorithm, then definitely it is for this purpose, not for something else. And then there's a nice website, crypty.com. So you can just try this website, crypty.com, and see how some of these algorithms work. So there are few algorithms given as examples, and you can try them and see how they do the encryption, how they do the decryption, ciphering and deciphering. Okay, so theory behind encryption is something similar to the image you see. There will be a key which will be used with the encryption algorithm and then the plain text. So it will produce something called the ciphertext. So this ciphertext will be decrypt using another key, which is called the decryption key. And then you will get back the same plain text. So based on the application, there can be two different keys for the same key. So we use mostly this encryption in different layers. If it was used in application layer, it can be used for things such as securing different data like secure emails or maybe sessions for database connections, even messaging. So if you are using messaging applications like WhatsApp, Telegram, or something that these days people use popularly, most of these applications, they use their own encryption method. Their own encryption method doesn't mean that is proprietary. They are also using some common ciphering algorithm, but they do it from their own way. So if you check your WhatsApp, then they say they have their encryption end to end. So the encryption starts from one user to the other. And then things like Telegram, they do from the user to the server and from the server to the other user. Services like Signal, they do again from the first user to the second user. So they do it in different ways. So, but basically it will be changing your plain text into ciphertext. So there will be different session keys, different keys based on your device or based on the session. So that is how they protect the content from intermediate attacks or the man-in-the-middle attacks. Then we can see applications like SSL or TLS in the session layer, and then if it's the network layer, then things such as IPsec will be there. So all these applications will be using encryption methods or cryptographical methods to do what they do. So this is the basic of what plain text, keys, and ciphertext. Then so the previous the slide we discussed about two keys, encryption key and decryption key. If the key, if both these keys are equal, then we call it as symmetric encryption. So in symmetric encryption, both the keys will be same. So most of these keys may have key length. Most of these algorithms, they have different key lengths like 40 bits or 256 bits. Based on that, the algorithm will use the key and the plain text to create the ciphertext. So if you go to crypty.com, you can try out some of these algorithms and see how the ciphertexting happens, and how you do the encryption and how you do the decryption using the same key. So if this is the same key kind of thing, then it will be called symmetric key encryption. So also sometimes this is called as a secret key algorithm. So this is in general, not a specific thing. So only issue with this is the key should be kept in private. Otherwise, if someone gets to know the key, then they can decrypt the ciphertext. So always need to keep the key a private, as a private entity. Then these are some examples of the available symmetric key encryption algorithms. So this is just for the slide. I will just skip. Then if the two keys are different, then we call it as asymmetric key encryption. So that is where you see a something called a public key and a private key. So this is one of the, again, commonly used system for many applications. They will be using two different keys, and one key is known as the encryption key, and the other one is known as the decryption key. Based on the application, the encryption can be commonly known as the public key, and then the decryption will be known as the private key. So what here happen is you publicly announce your key, which is known as the public key. So anyone, if wants to send you a message, then what they do is they just encrypt the message with the public key. And then when you're decrypting, you use your private key, which is private only for you. So that is the asymmetric key encryption in 1 minute or 1.5 minutes. So that is the basic idea. So most of the time, this key types, they can be differed, as earlier said, public and private. So in normal communication, we use this public key as for the encryption, and then decryption for private by the private key. But still, we can use both keys for the both purposes. You can use the private key for the encryption as well as the public key for the decryption. So if you encrypt it with the private key, then it is possible to decrypt it with your public key. If you encrypt it with your public key, it is possible to decrypt it with your private key. But let's say if you decrypt, let's say if you encrypt your message or your text using your public key, you can't decrypt it using the same key or the same public key. So that is the algorithm. So you can't encrypt, you can't decrypt using the same key. In most cases, we keep the public key for encryption and private key for decryption, because the importance of the ciphertexting will be getting the message securely from some location to the other location. So the person who will be reading should have the capability of decrypting that. So that's why it's called private key. So most of the time, this asymmetric key encryption can be used to transfer something between two parties. But in this case, you don't need to transfer your secret key from one place to the other, because public key is always public, so anyone can use that, and the private key shouldn't have to go anywhere. It will be just sitting with you. So, but in case of the symmetric key, when you create a key, you have to send the key in a different channel or in a different way to the other party, otherwise they can't decrypt the message. So that is one of the advantages of having asymmetric key. So you don't have to share the key in a different way. So in normal cases, let's say if you want to encrypt some, let's say if you want to encrypt a document, a Word document or a zip file using a password, what you do is you encrypt that file, you put that password to that file, and then you have to send the file in a one channel and then the password in another channel. If let's say if you encrypt a file and then you put it in an email, and then again on the email body you type this is the password, then it doesn't make any sense to others, because the single email will contain the encrypted content plus the password. So it doesn't make any sense. So you have to send it into two separate methods. Two separate methods means not in two different emails, but in two different ways. So I have seen people, so I'm just changing the track here. So I have seen some people where they encrypt some sort of a file. Let's say if you want to send a password protected file from one place to another place, what they do is they put a password to the Word document or the Excel sheet, what they want to secure, and then they attach the file into an email, and then they type the password on the same email saying this is the password. But if that email communication was intercepted during the transmission by someone else, then they can receive the file, receive the protected content as well as the key. Again, let's say if you send the email in the first email and you put the password on the second email, still if there is someone who's watching your communication, then or tapping your communication, then that party can download the secure content as well as the password. So when you are sending something like that, don't do it in the same channel. So most of the time we used to do password sharing in things like end-to-end communication, end-to-end encrypted communication provided applications. So for example, let's say if you want to send a password to someone, you can use some application like maybe WhatsApp if you trust that application. So I know WhatsApp is not a trustable application due to their different policies, but things like Signal you can use to do the password sharing from one place to the other, and then you can send an email with the encrypted content. So the content will just be encrypted and no one can open that, but your password will be securely transmitted in a secure channel. So that is some additional thing that I just wanted to mention. Okay. So the asymmetric key encryption happens like this, as I said earlier. If still someone doesn't get it, there will be a key. So in this case, Alice has two keys called Alice public key and Alice private key. So if Bob wants to send something to Alice, what Bob does is Bob will first find the public key that belongs to Alice. So mostly it will be a public key, means it will be publicly available. Then Bob uses that public key, Alice public key, to encrypt the message. So once Alice receives the encrypted content, Alice will decrypt it using Alice's private key. So that is the basic idea. Then there are a few popular algorithms. So mostly we use RSA. So this was developed in I can't remember, maybe 1950s sometimes, but still the encryption method is okay, and there are issues with small key sizes. So because of that, we are trying to use high key values. So most of the applications today use 2048 bits or more than that. So that is for the more protection. I normally say you should use at least 4096 bits because it's more secure. But if you are using 4096 bits, then it might take some time to generate the key as well as generating the doing the encryption and decryption because of the length of the key. But if you are using a new computer and modern or something like i5 or i6 or maybe some other processor, then it won't be a big issue. Then there's another popular algorithm called ElGamal. So mostly the ElGamal is like used in web application as well as stuff like PGP. Yeah, so these two will be commonly used in many applications. So we see how we can apply them. So one of the application is the session keys. Session keys. So when when creating a session key, what do you think about that? How to send a key? So normally in application, in different applications, how they do the encryption is they use symmetric encryption to encrypt the actual content, but then they will use asymmetric encryption to share the key. So session key encryption means this is how they encrypt the session key. So there will be a key for each session, and that key will be encrypted using asymmetric key. So the data encrypted using symmetric key, and the password or the key for the symmetric encryption is encrypted using asymmetric encryption. So you can see the see some example from the block diagram here. So some ciphering method will be used with the plain text and a session key, and then they get the ciphertext. And the session key will be again encrypted using the recipient's public key, and then both of these will be sent to the recipient. So if someone intercepts this communication in the middle, what they will see is some encrypted text. So they can't see a difference between the actual data and the key. It will be just encrypted content. Once the recipient receives this, first the recipient will use the private key to decrypt the session key, and the decrypted session key will be used to decrypt the actual message. So that is how the session key encryption works. So this session key, this sort of encryption method is used in SSH. So we know SSH. Everyone here must have used SSH at some point. So we use SSH to remote log into different devices, different services. So SSH is the protocol defined in RFC 4251 for secure remote logging for different services in an insecure network. So what this does is provides the secure channel between two ends, and then data confidentiality integrity. So that is why we use this SSH to do the remote shell applications or remote logging. even sometimes people use SSH for secure data transmission as well. Data means the not the text but the big data. One of the key advantage of this is SSH will check on your confidentiality because of the encryption, and then again it will check on your integrity, whether that was integrity means if someone sends something from one place to the other, the recipient should know whether whether that data was the actual data sent from that place to the recipient. So that is integrity. So SSH can be used as the transport layer protocol. So it can give you the server authentication, confidentiality, integrity services. Most of the time it have the data compression, and then it runs on the TCP layer. And then there will be different user authentication protocols for SSH. So you can use the server-side authentication as well as the client-side authentication. So this SSH user authentication, it runs on top of the TCP layer or the SSH transport. So first it will create the SSH transport and then the authentication. So then the SSH connection. So what SSH connection does is it connects both the transport layer and then the user authentication, and then creates a tunnel between two ends. And because of this tunnel creation, it can be used for creating an interactive shell between the two ends. So there will be TCP port forwarding for SSH. So basically port 22 is used in general, but you can change the port number. So if you change the port number, then both ends should know what port that they should use. Sometimes, most of the time, so X11 connections can be used, will be used for carrying the SSH data. So how SSH happens? So the first step will be a client opening a connection to the server. Then the server sent the client its public key. So this is again another public key saying, which is known as the server key, that changes every hour. So there will be a server key which changes in a defined time. So the client then compares the received host key and key against the host key that this client already has. So the client should have, if it was the first time, so when you connect to a server for the first time using SSH, most of the time your client will ask you whether to trust the received key from the host. If you trust the host, then you can simply click yes for that. So the second time when you try to connect, your client will automatically check the previously accepted key against the newly received key. So if these two matches, then you can start the communication. Or otherwise, what will happen is, if those two doesn't match, your client will reject the incoming connection, saying there's a key mismatch. So that can happen if you, let's say first you first you install some Linux server, let's say an Ubuntu server, and then you try to SSH into that server, and then you do something, and at some point your server crashes. So because of that, you need to reinstall the server. Then you reinstall Ubuntu, and then you put the same IP address. But now when you try to log into the second, login into the new installation, your SSH client will simply reject that connection, saying the new key is different from the previous one, because the key generation happens at the installation of the SSH server. So the first key or the first installation will have a different key other than the second installation. So those two keys will not match. Because of that, your client will reject your connection. So in that case, what you have to do is you have to remove that known key or the saved key from the database of your client. So actually I'm a Mac OS user, so I'm not exactly aware of how Windows do this. So if you are using some application like Putty, most of the time it will ask you whether it should be accepted manually or not. But if you are using a Linux based or a Mac OS based operating system as your desktop or laptop, then it will store the key, and it will do the automatic comparison. So then you have to go into the SSH known keys. There's a file called known host. You have to go into the known host and remove the existing key manually. Otherwise, you can't log into the server. So that is how SSH step 2 works. Then on the step 3, what happens is the client generates a 256 random number, which is known as the session key. Then picks an encryption algorithm which the both parties are agreed to. So during the first connection or the previous step, server will send the client the set of algorithms that the server supports. So the client can select one of them if client already supports those applications. So most of the time, client will try to go for the most secure algorithm unless that is defined or hard coded to use something different. Then they encrypt that session key using the host key and then the server key. Then it will be sent to the server. So how server decrypts the session key? So that will be the fourth session. So the received session key on the server side will be encrypted using this server key and then the public key. So the encrypted data should be decrypted using the actual private key. So those two will be already in the server, so they can be decrypted using those two private keys. Then both server and the client will have this session key. So if you have the session key, now you can create the transport level encryption. So basically an encrypted tunnel between you and the between the client and the server. So the image in the bottom will describe the same thing. So first the client requests a session, then the server responds with the certificate. Then the client creates the symmetric key, encrypted with the public key, send the encrypted key to the server. Server decrypt the symmetric key using the private key, and then they start the session encryption based on the symmetric key. So the previous session key encryption was used in this SSH sessions, where they use symmetric key for the actual encryption and the asymmetric key encryption for encrypting the session key. Any questions? So yesterday I shared a Google Doc with you, and most of you requested access to that yesterday, and then again just now I received few other requests. Okay. So if you have any questions, you can ask, or otherwise you can put them on the chat, so I can answer them during the session. Okay. Yeah, so there's someone saying okay, so that's actually a good question. So so what happens with the okay, so there are like two questions. I will first answer the first one. So when you try to log into a server, at the first step, the client asks to do a secure session from the server. Then the server sends you a message with its public key and the session key, another key, which again relates to the second question, and the set of keys, set of algorithms that it supports, that the server supports. So your client should support whatever the algorithms that were sent by the server to be connected. So otherwise, if your client doesn't support those algorithms, you need to you have to add them into your client application, otherwise you can't log in. So the question is asking the question from Pema is, I hope I pronounced your name correctly. So I suppose you tried to log in to the same server using the same machine. So what can happen is if there was a server upgrade or a client-side update of your operating system, sometimes there are some updates of the operating system or the SSH server update, which removes some of these methods, key exchange methods. So in this case, Diffie-Hellman group 1, SHA1 have been removed from your client side. So in this message, it says their offer was SHA1 of Diffie-Hellman group 1. So what happened was the SSH server, it was running on a old operating system, I suppose, because most of the time these days these applications don't use SHA1 Diffie-Hellman. Anyway, so when you update your once you update your client definitely rejects the old exchange methods or the algorithms. That is because most of the time the operating system vendors or the manufacturers, they remove some of the applications during their updates due to the insecurity of some of the protocols. So in most of the new clients, this SHA1 have been removed. So what you have, the best way or the best thing you need to do is to update your SSH server from the server side. Or else you can again change the SSH client settings to accept that, but it's not a good way to do. So the client rejects that because it's already been removed from the system. So it's not a good thing for you to include it again. So the best thing is to update your SSH server. Then the other question from Lawrence is like, what is the other key? So if I go back to the second step, so this server sends another key. So actually the server sends the public key plus the server key, a different key. So that key can be changed every hour. So that's why sometimes during let's say if you are in a unstable connection between the server and the client, sometimes your SSH connection drops. That happens because sometimes the TCP connections might not receive the changed server key. So the public key is a static one, but the server key will depend on the session. So the second key will be changed at a given period based on the server settings. So it's not exactly a 60 minutes or 1 hour. It can depend on the server settings. So the second key, so actually the public key and the other public key known as the server key will be used as a single key for the encryption of the session key. So the server key, the second part, will be changed at a given interval. So the issue with dropping in an unstable connection is if you didn't receive, or if you had some issue with receiving the second part of the key, when it changes, the connection drops because you can't maintain the connection. So that is why two things again. Why using two keys is for the more enhanced security rather than simply using a single host key. Okay, so then how to do the SSH user authentication? So the user authentication normally happens can be used with different methods. So there will be like the public key authentication, user authentication. There will be a password user authentication. And then there can be a host-based user authentication as well. So public key means you can share your the client's public key with the server. So the server authenticated the client using the public key, not like the earlier case. And then the password, where server asks you to enter a password, and then the host base. You can again create a password for the host and then set up connection to the server. So anyone who try to connect from a particular host is authenticated on that server. So most of the time we don't use host-based authentication in general because it's not a secure method if there are multiple user accounts in your device. So if it's a personal device, then that is fine. But let's say if it's a device with multiple user accounts, so these days there are a lot of operating systems supporting guest access. So if your server supports the guest access, if your host support the guest access, then if there was some host-based authentication, even your guest can log into whatever the secure server that you are trying to SSH. So most of the time these days we are not using host-based, but public key and passwords can be user-based. So there will be those things heavily used to authenticate SSH connections. And then there will be few timeouts, like the authentication attempt session time. So recommend the 10 minutes and then the number of attempts. So you can try, you can change it up to 20 attempts. So this is not the way you put your password, but this is the way how it automatically try to identify the session ID. Most of the time, the things like passwords, they have, I think, 3 or 5 timeouts. So if you enter the password wrongly for 3 times, then you will be dropped out from the session. So something like that. So before you create the user authentication, the HTTP SSH tunnel will be created, because all your user authentication will again happen inside the SSH tunnel. Okay, so for SSH user authentication, we can try them. We can check few of them during the tutorial which I have written for you. Okay, I just received another request. Then another way of using cryptographical application is the message digest. So the message digest is how you fingerprint a document. So what happens is you will be using a hashing algorithm to create a hash of your message, of your text, and then you are trying to send that in a plain text mode. So I will explain it. So the purpose of the digest is to provide proof that data is not altered. So that means when you create a hash, if the data is changed during the transmission, if you recreate the hash, the second hash should support, can be compared with the first hash, and those two have to match. So if something happened during the communication, if something got tampered or if something got dropped during the communication, the comparison should fail because it does not matches. So these hash functions, again, they are some sort of a function that cannot be done in the reverse way. So it's infeasible to reverse the function. You can't recreate something. You can't recreate the actual message from the hash. You can create the hash from the message, but not the other way around. But in the encryption methods, encryption and decryption, you encrypt the message and you get the ciphertext, and then you decrypt the ciphertext and you get the plain text. But in case of hash, it's not the way how it works. So you can't reverse the function, and then it's very rare you can construct two messages which will give you the same hash. Okay, so for example, let's say you create a password, and then the password gives you a hash like ABC. So the hash is ABC. Can you create another text which will give you the same hash? If the hashing algorithms can give you something like that, then it won't give you the required functionality of that hash function. So the hash function should not give you a single hash for two different messages. So that is one of the key things with these hashes. So today we use mostly MD5 hashes and SHA-1 or more than that hashes. So there will be different hashing mechanisms. I'm not going to go into details of these, but why we need the hash. So this is the message digest. So this is not just the hashing. This is message digest. Hashing and message digest means you create the digest by putting a secret key. So this is called message authentication codes or MAC. So in our world, we use MAC for different things. So in this case, MAC means message authentication codes. So the message digest will be created with a key. So once you create the message digest with a key, it is called a message authentication code. So this digest is kind of encrypted with a secret key. So the testing of the digest can only be done if the other party have the secret key to decrypt the algorithm. It's like you do a hashing of a particular message and then you receive the hash. And then you do from the receiving end, you do the same hashing algorithm, and then you receive the hash, and anyone can compare those two. But when you put a secret key on top of that, what will happen is only the two actual parties can find the actual hash. So it doesn't mean you can decrypt the hash using your secret key. It will just encrypt the hash at the both ends, and the transmitted digest will only contain a encrypted hash, not the encrypted message. Then with the message digest, MACs, or the message digest codes, then we come into the digital signatures. What is a digital signature? So the digital signature is where you encrypt that hash or the message digest with your public key, with your private key. What now we are doing is we are trying to send some encrypted message to the world, to the public, encrypted with our private key. So anyone out there, they can decrypt my message using my public key. So the goal of doing something like this is to guarantee the source of the data. If I want to prove that I am the person who's actually sending the data, then I can put my digital signature on a document. So the first goal of doing this is to guarantee the source of the data. And then the second one is the proof that the data has not been tampered. So if you have a digital signature, if the digital signature fails, then that can be either two things, that is either the source is invalid or the data have been tampered. Okay, so before going into details of the digital signatures, I just want to let you know this digital signature is not something that you sign digitally on a document. So sometimes people think digital signature is some signature using something that you use digitally or a scanned image on a document. So if you put a scanned image on a document, if you put your signature scanned and then you put it on a document as an image, then it is not the digital signature, it's just a image staying in your document. It can be the photocopy of your signature. Then again, there are some applications where they try to get your digital signature as in the form of your actual signature, where they ask you to draw your signature on your trackpad or using your mouse. And then they convert that pattern into a digital format. Then what they do is they use that format to generate the private and public keys of your digital signature. So if you don't have a public key, private key generated, you can use some software like Adobe Writer, or I think even Adobe Reader supports that, and even Mac OS Preview to generate a such digital signature. So in that case, your signature will also look like a normal signature that you sign, but it will contain some additional details like the date you signed, the location you signed, etc. So that will be actually a digital signature. So if someone wants to test the digital signature for the validity, the recipient can simply check the validity using the same software which were used to sign the application. So there are proprietary software mechanisms how they do the digital signatures, but what I am going to show you is the simple way of doing it in general. So one of the other things with digital signatures is these days these digital signatures are heavily used in a lot of locations where they accept digital signing as a legal binding, especially in the pandemic period. Many businesses converted their business ways into the digital form, and now they are accepting digital signatures even for a lot of government activities as well. So you can do the digital signaturing, and you can sign the digital documents with your digital signature, and then you can even send it via an insecure or non-secure channel, but still the receiver can check the validity of the document. So this document will not be a secret document for anyone. It will be a plain text document if you send it through a plain text channel, but the validity of the document relies upon the source of the signature and the integrity of the document. So the document integrity, or whether it was tampered or not, will be checked based on your signature. If it's tampered, then definitely your signature will fail. Hmm. 10:30. So this is let's see. Okay, so this is the process of how digital signatures work. Key generation, signing, and verification. So at the key generation, two keys will be generated, the private key and the public key. Then at the signing part, the signature will use the message digest and the private key of the owner or the sender to create the signature of that document. So the signature of a document means first they create the digest of the message or the hash, and then that hash will be encrypted using your private key. So earlier we saw this part with the hashing algorithm, and then we saw this part with the MAC or message authentication. Now in digital signatures, what we do is we use the private key to do the encryption of the hashing or the hash. So the message, let's say message was ABC, and then it gets hashed, let's say XYZ, then the XYZ gets encrypted using your private key. So based on that, the digital signature will have a different form, which is encrypted using your private key. So this message or this encrypted content will be sent to the receiver, and then the original message again will be sent to the receiver. So the receiver will receive two things: the original message and the encrypted hash. Then the receiver will calculate the message digest again using the digest algorithm. So the algorithms have to be first decided or first agreed upon by both parties. Otherwise, things like that key exchange method mismatches can happen even with the digital signature. So if the algorithms they matches, they create the same hash on the both sides, and then the receiver uses the public key of the sender to decrypt whatever the encrypted content. So the encrypted content will be the original digest of the original message. Then the receiver will receive the original digest from the encrypted content, and then he can check whether these two are equal. If these two compare, or if these two are equal, then the receiver can accept the message. So that is how digital signatures work. If you have received any digitally signed content, you can simply see the validity of the content. So in this case, we are not hiding anything from anyone, especially in the message, the plain text one. So the plain text will be just plain text, but here you are proving that this message was sent from the actual sender and it was not tampered during the communication. So that is the purpose of digital signatures. Okay, so I guess we can stop for break before continuing. Yeah, shall we break for half an hour? So 10:30 in Colombo now, and we'll start at 11 in Colombo time. Okay, see you in half an hour.
Thank you.
Okay, so good morning again, good afternoon for some of you. So welcome again to the second session. And so previously, actually, we carried few things on cryptography, but actually, I guess we are like late for the session. So I will just try to go quickly through some of these slides again to cover the whole thing, and then we'll continue with the rest of the work that is scheduled to today. So one of the other things that uses cryptography heavily, or some application that should be used by you, is the PGP, or pretty good privacy. So PGP is one of the ways you sign, one of the ways you do the encryption for emails. So it's not just emails, but the today we heavily use PGP for emails. So the PGP is based on asymmetric key cryptography, as well as the way how you build trust among the other users. So in this case, you can see the 4 points I have kept. Alice has a private key, and she has put its connected public key on her web page, or a key management public site. So what a key management public site is: so once you create a public private key pair, you need a way to publish your public key. If you have a personal website, you can simply publish it in your personal website, or else there are some sites called key management sites where they store all the public keys which are uploaded into that site. So any person can just go into that website and search for a particular public key and get it from there. So in this case, Alice has put her key in a particular website, or on a key management public site. Then if Bob wants to send her a message, if Bob wants to send a message to Alice using PGP, what Bob should do is, first he should go to that particular website. It can be either her private website or the key management website. Then Bob should download the public key of Alice. Then Bob can encrypt his message using Alice public key, and then send that message to Alice. Once Alice gets the message, she can decrypt it using the private key, which is only a property of Alice. So PGP, so in this example, we are using PGP as the encryption method, but again, PGP can be used for digital signing as well. Then the PGP completely works on something called Web of Trust. So it's like, if you trust that key management server, you can trust anything on that key management server. Again, even in the key management server, if you see someone's public key, if you trust that is the correct public key, you can put your signature on top of that public key, saying you trust that person. So likewise, if let's say if there are 5 persons trusting Alice, then Alice public key can be signed by 5 of those people, So anyone who trusts those people, those 5 people, can again trust Alice because they already trust someone who Alice knows. So something similarly is called the web of trust. So the trusting a fingerprint of a ID is based on completely the know-how of each person. So I'll just go quickly to the other slide. So this is an example from actually from Wikipedia, the image. This is a way of going through the web of trust. So Ingo is a direct trust of Ava and Axel, and then Manuel and Manuel trusts Ava as well as okay, so Manuel trusts Ava directly, but none of the others. And then Susie trusts Manuel. Manfred trusts Susie. So the trust means if Ingo is trusted by Ava, that means Manuel can trust Ingo because Manuel trusts Ava. And then Susie again can trust Ava because Susie trusts Manuel. Similarly, Susie can trust Ingo because Susie trusts Manuel and Ava both. The same way, Manfred can trust Ingo because Manfred trusts Susie, Manuel, and Ava. The same goes with Axel. Manuel can trust Axel even though they don't have a direct connection, but they have an indirect trust because of the other people. So this web of trust is the key point of PGP where the PGP trust builds. So so you can simply trust any person's PGP key if that is trusted by someone else that you trust. So similarly, that happens. So this is an example from an open PGP key server. So there are a lot of PGP key servers. One is maintained by MIT, and there are a lot of other open PGP key servers. You can just go to those. You can just Google open PGP key server, and then there you can find a lot of things. So this is one of my PGP keys that I have uploaded into these key servers. So you can see my Gmail address, and then that Gmail address have been signed by 4 other people. So if anyone trusts any of those 4, then that means they can trust me as well. So if I send some if someone wants to send something to me, they can download my public key, which is trusted by the others. That means this is the actual private key, actual public key. Then they can download the public key from this website, and then they can send me the message using by encrypting these public keys. So later I can decrypt it using my private key, which belongs to this key, which belongs to this public key. So that is how PGP trust builds. So this is an example Pgp encrypted mail from my learn email to a Gmail. So you can see the beginning of the PGP message and then the end of the PGP message. So it's just an encrypted message. Then this is the same message, but now this is not encrypted. This is just signed. So This is encrypted. This is signed. So the difference between these two methods is when you encrypt, it's just encrypted. So it's the whole thing gets encrypted. But when you sign, you have two parts of the message. First is this plain text message. So the actual message is this. It starts from here, test sign, and then ends with my website. So these characters are then hashed and then created a signature. So the below or the second part is the PGP signature. So once someone received that, they can check the signature and check whether the message is correct or not. So in this case, message is in plain text, but the validity of the message can be checked based on the signature. So most of the security people, they use PGP signed mails if they want to send a secure mail to someone else. So if you are following security updates from different security organizations, then you will see their updates come as a PGP signed message. That is because of the magnitude of the content. So if someone wants to send something important to someone, they want to verify that this content is sent actually from them. So if you want to send, if you want to send something to someone that is important, and if you want to make sure that this was, you need to tell them that it was sent directly from you, then you can simply use something like signed emails. So in this case, it's PGP signed emails. For example, you have been receiving few emails lately from our registration system called Indigo, but those emails came from my email ID. But what happened was, like, I never typed that email in my email client. I just included that message in the Indigo system, and the Indigo system sent you those messages. But it came as a message from me, from my email. So in that case, can you trust the recipient? In this case, yeah, it's still me sending those emails, but I am using a different system to send an email on behalf of me. So the same thing can be happen to any system. So someone can use your email address and send another party some email. So that party thinks this actual sender is you. So if that email is kind of an important email, or if it harms the person who receives, what will happen? So people will think you are actually sending these emails. So because of that, you need to verify whether you sent that or not. That's why something called PGP signing is there. So the message is in plain text, so we don't care whether someone else read the message. We only care about the validity of the sender and the integrity of the content. So this is again how the PGP process works. So this is the encryption process and the decryption process. They use the session key with the encrypted content, and then they encrypt the key with the public key, and then they send the ciphertext and the encrypted session key. When it is received, the encrypted session key again decrypted using the private key, and the message is decrypted using the already decrypted session key. So that is how the process works. So this is what we earlier discussed. So the same thing. Then I'll go to the digital certificates. Actually, we will be doing some. I will try to find some time on the third day or the fourth day to do the PGP examples practically. So if you already have, if some of you already have PGP keys, you can send me an email with your with my PGP key. So you can search my name on the key server, and then you will find my key. Then you can try to send PGP mails to me so we can test some emails. Likewise, we will discuss how to do some PGP mails, maybe the third or the fourth day. So then we come into the digital certificates. So the digital certificates are where we use a third party, a trusted party, to trust the public key of another party. So the trusting party, in this case, we call it as a root CA or a certificate authority. So the certificate authority is an entity that is trusted, that should be trusted by everyone. And then if that trusted party trusts a particular certificate, that means the others can trust that particular entity as well. So then there can be a question asking whether we can become a CA. Yes, you can become a CA, but the only thing is other people should trust you. So there are few standard certificate authorities. There are like a lot of certificate authorities at the moment. So VeriSign is kind of an industry standard authority. So what they do is, so from the beginning they were there. So now people trust them, and if you want to get trusted, what you have to do is you have to ask them to sign your certificate. Then they will sign your certificate. So once you send your public key to the others, they will check your public key and see who trusts you. And if they see a common CA or a popular CA, then they will trust your public key as well. So that is what happens. So how they do this certificate trusting is, they will put the senders or the public key that are in question will be signed with the information of the identity of that particular sender, as well as the certificate authority's private key. So the signature of that particular encryption will become the certificate for that particular entity. So the public certificate of a entity means the public key of that particular part, and then the signed content of the public CA. So this is the process of HTTPS. Why we talked about CAs? Because HTTPS basically runs on the public and private key combinations, and if the HTTPS have to be trusted by all the parties, then you should use a certificate key, a certificate that is trusted by a common or a non-certificate authority. So the server generation happens like the steps 1, 2, 3. First, you create the private key, and then something called Csr generation. Csr is like you create a request to do a server creation. So that Csr will contain your public key and then your details. Then you send that Csr to a CA along with your server details like the FQDN, the addresses, telephone numbers, or whatever the details that they ask. So the Csr contains the public key of your private key and then the server details. Then the CA verifies those details based on their way of verification. They might do a manual check. Sometimes they might do a digital check as well. So depending on the magnitude of the service they provide, they will sign your CSR, and then they will create the public certificate for you. That public certificate will then send to you, and it will be called the public certificate signed by a particular CA. So that this public certificate contains two things. That is the server public key, which was sent with the CSR, and then the signature that is signed by the CA. Also, the public certificate of the CA is already should be already distributed to all the clients of popular browsers. So if you are a browser manufacturer, if you are a browser programmer, then you should contact these CAs and get their public certificate if you want people to use your browser, and if you want to publish your browser for other people. So if you don't put those public certificates into your browsers, then people won't be able to use HTTPS from your client. So by today, most of all these CAs, public CAs, they have given their public certificates to all the browsers. So once a public certificate is sent to a client will decrypt the signature using the public certificate of that particular CA. So this is the HTTPS process where the client sent an hello message. So that message might contain all the algorithms they support and a random number generation. Then the server responds with the server hello and then the supported algorithms, and then another random number, and then the SSL certificate. Then the client verifies the certificate with the CA public key, and then the client encrypts the pre-master key with the server public key, and then that is sent to the server. So how you do the pre-master key is like the key calculation is will be used with the random number 1, random number 2, and a predefined master key. So the random number will be on the both sides. So the master key will be the key that will be used for the encryption channel. So this is the HTTPS process, and then how SMIME works. So actually, I'm not going to go into details of SMIME, but SMIME is again something similar to PGP, but in this case, we are not using a key server, but we are using a trusted certificate authority, a third-party authority, to provide a certificate. So in this case, you can see an example SMIME certificate. So you can see the message was signed by someone with the email address that is provided, and then the certificate was issued by the particular CA. So you can use SMIME to do the encryption as well as the sign. If both of you have encrypted SMIME encryption enabled, you can do the messaging with the full encryption. If the receiving party doesn't support SMIME, or if the receiving party doesn't have the SMIME certificates, then the sender can just sign the message without encrypting. So in that way, the receiver, if the receiver wants, then they can simply check the validity of the message by testing the sign. So in this case, you can see both signature and the encryption. Signature and the encryption. So so this was a screenshot taken from a message that I received. So I was using SMIME for my email. So the sender sent me a message encrypting. So the encrypting means they already signed and then encrypt. But if you want just the signature, you can simply remove the encryption. So those are some options that you have from your email client. So if you use an email client, you can do PGP or SMIME easily. So in this case, I was using Thunderbird. So Thunderbird can be simply converted into a secure email client using SMIME or PGP or both. If you use Outlook or some other mail client, they can also adapt to SMIME as well as PGP, but you need to find different extensions for that. So as a security person, I don't like using Microsoft Outlook for emails because we don't know the inside of Outlook, but Thunderbird is kind of an open source software, so it can be trusted. So that's why we use Thunderbird. So this is actually coming from the Thunderbird. And if you use Thunderbird or if you use Outlook, doesn't matter, you can simply use PGP or SMIME. But if you use a web-based client or a web-based email service, most of those web-based service doesn't support SMIME or PGP. So things like Google or the Gmail browser version doesn't support SMIME or PGP. But if you sync Gmail with Outlook or Thunderbird, then you can use SMIME or PGP. But still, Google will support the signature verification. So if there is a message signed by SMIME, then Google will give you the verification for that message saying the sender is verified. Let's see whether I can show you some email. Okay, so so this is one of the emails sent from my email. You can see my email tilnatlan.ac.lk, and this was sent to a mailing list. And then so this is my Gmail, and so this is not tilnatlan.ac.lk. This is something else. This is a Gmail account. So actually tilnatlan.ac.lk is not a Gmail account, it's a postfix account. So this is the received message. So this is the plain text message with some images. And once you click show details, you can see this has a green tick saying verified email address. If you check the sender info, you can see signed by tilnatlan.ac.lk issuer. So this is the SMIME CA, and then the validity of that particular certificate was this. So yeah, so this was sent in 2020. So you can see the message is verified. So that means this is using an SMIME certificate. But Gmail doesn't support PGP. If you look at services like Yahoo doesn't support SMIME or either PGP both. So in that case, you will see an additional attachment in your message saying SMIME. So the attachment might only contain the name SMIME or something similar. So that means it is just the signature. So they just attach the signature as an attachment. So if you want, you can verify that signature using a third-party software. Okay. Okay, so while doing the lecture, I will just share the attendance sheet like yesterday. It will be the same attendance sheet, but go to the day 2 sheet and then enter your name. I will share the Google Sheet. Please log into that Google Sheet and enter your name and email address so everyone can get the attendance from there. Okay, I'll go back to these slides. Okay, so this is the last thing that I was planning to discuss on cryptography applications, so SMIME. And so things, I'm not going to show you how to do SMIME in the practical scenarios, but you can simply download this. You can simply find SMIME supporting CA. So in this case, I'm using Commodore RSA CA for the emails, secure emails. So that was a free service provided by Comodo, but I'm not sure that is still available. Then you can find a free CA if you like, if you want to use SMIME, but most of the time SMIME again comes with the price. So if you want to put SMIME, proper SMIME certificate, you need to buy it from a popular CA like maybe VeriSign and then use it, but it might cost you something, because most of these CAs, they don't do it for free, they do it for a cost. But in case of PGP will be free, because it's just something that builds on the web of trust. So PGP is free. So if so, you can always use PGP if you want to use email signatures. Okay, let's go quickly to the okay, so if you look at the agenda page, there are 3 tutorials linked on how to do SSH with multiple authentications, and then how to generate HTTPS, and then UFW, which is the firewalling mechanism for Ubuntu. And then again, I have kept some presentation by a friend of us about Let's Encrypt and automating things. So you can also refer this in leisure time. If you go to SSH tutorial, so there are some guidelines on how to SSH into a Ubuntu server using PuTTY, and then how to enable public key authentication on PuTTY. We have done this tutorial for Windows-based users. So most of the time, Windows-based users, they use PuTTY as the SSH client. Then on PuTTY, you can have a different application called PuTTY Gen. So PuTTY Gen will create the keys that are required to have the public and private key combination. So you can generate the key by selecting the parameters. So here in this case, we are creating an RSA key with 2048 size depth. So you can create RSA key with even 4096 as well. So once you create the certificate key, this will be your public key, and your private key will be kept privately. So you can here see the button asking to save your private key. You can save those both those keys by clicking these 2 buttons, save public key and save private key. Again, something, when you generate the private key, it might ask for key phrase where you put a password for the private key, but in many cases we keep it blank, because the purpose of having a certificate is just to have the authentication based on the keys. But once you put a password, it's good for the security of your private key, but you need to make sure, you need to remember the password for the private key. Otherwise, you can't do any communication using those 2. So in this example, we are using a password for the key, but simply you can neglect that as well. And then once you save these two keys, you need to upload the content of the public key to a place called authorized keys. So what you do is first you create, if this file folder is not in your browser. Okay, I will first try to do an SSH. Okay, so there's a question asking whether we need to use PuTTY if you are using Linux. No, I will come into Linux in a minute. First, I will go through Linux, Windows, because Windows is one of the ugly truth that we face, because many people use Windows. I don't know why. Okay, so I will share my terminal. It's not shared. Okay. I will just share my screen. Okay, so you can see the whole screen, I guess. So this is the tutorial, and then this is my SSH screen. And what I want to show is the location. So in this case, you can see that I am logged into a SSH server, Ubuntu server using SSH, and then if I do an ls, you can't see anything, but if I do ls -a, you can see all the hidden files. Since I've been using SSH to connect from this server to other places, you will see a folder called .ssh. So the contents of that folder is something like this. If that .ssh is not there, you can simply use the make directory command, but make sure that .ssh is on your root directory, on your user's root directory, not the /root. It should be your working root directory of the particular user. And then you can create a file called authorized keys. So if I cat authorized keys, you can see something like this. So this is my MacBook accounts private. Actually, my MacBook user accounts public key. So my username is something like this, because this is Office provided device. My username is like 29 something, and then you can see the username, and then this is the RSA created public key. So what you have to do is, once you in the PuTTY, once you generate this public key, you have to copy that public key into this authorized keys. After that, on the PuTTY configuration, you have to give your private key as shown in this screenshot. then what will happen is your private key will be, your public key will be checked from the server side, and then your communication will be encrypted 2 ways. So you won't need to enter a password once you do that. For example, I can't show you this exactly because I have configured something else in this server. Okay, so I will just go through this thing and then we'll come back to here. So the question whether you need to check, you need to do putty on Linux. No, you don't need to do Linux. If you are a Linux or Mac OS user, there's a link below on the bottom on showing. So that's actually a third-party tutorial, but it shows how to generate the keys. So this is for Mac OS actually, but it will be same for the Linux. First, you need to generate your keys, and then this is how you create a different bitrate key. And then once you create the key, you will see some files on the same location that I can show you in my other window. Okay, so this is my root location of the Mac. So if I enter ls-a, you can see a folder called .ssh. If I go to .ssh and put an ls, you can see few things like idrsa, idrsa.pub, and non-hosts. So the non-host is the location where we store all the servers that we were used to log in. So these are the servers that the public keys of the servers that I were used to log in. So that is where you need to remove the entries when you, the example that I took, if you are connecting to a new server with the same IP, but if you can't connect, then you need to remove that entry. For example, if let's say this one, if I want to change the server, then you need to remove this one. The other two keys, the ID RSA is my private key generated by that SSH keygen, and then this is my public key. If I cut my public key, I'm not going to show you my private key, but I can show you the public key. So this is the same key as in the other screen. So this is on the server, and this is on my Unix based OS. So what you have to do is you have to first copy this content into the authorized keys file. So that can be done using a single but a long command like this, and it will be automatically connected. And then from even either you used putty or either you use Mac OS, edit this file on your server and make password authentication into no. Most of the time, the modern operating systems, they will even in this file in this server, I haven't edited that because most of the something happened to myself. Anyway, most of the time there, you might not need to change this into no, but if this doesn't work, change this parameter into no and restart the SSH service from your server side. So this is how this is done on Ubuntu or any Linux or Mac OS based device. Then the actual thing is how you enable the two-factor authentication. So two-factor means you can use either password or either the public key or a randomly generated key. So in this case, we use a randomly generated key, which is an OTP, one-time password. So this one-time password, you need to have either an SMS generation or some application that that creates the OTP. So SMS creation is possible if it's a web-based application, but in this case, since we are trying to SSH, it's very much difficult to connect an SMS generator and SMS gateway, but still it's possible, but it will make things worse. So the easiest way is to create OTP based user OTP based application like the one we use here in the Google Authenticator, but there are a lot of other OTP generators, not just Google Authenticator. There's something called Microsoft Authenticator, then there's something called OTP generator. So they can be installed in any your mobile device, Android, iPhone, or anything. So you can simply download the Google Authenticator into your phone, and then you need to do some changes into your server. So first you need to install the module that allows the Google Authenticator into your server, and then as your user, not as root. If you are using a particular user, you have to run this as your user, not as root. But if you are SSHing directly as a root, then make sure that is root. Why I am saying this is once you run this as the user, they will change some, create some data into your user account. But if you run it as sudo, or if you run it as a different user, that file might not be created correctly. So make sure this is not sudo if you are running as a normal user. Once you run this, they will give you a QR code, and this QR code have to be scanned from your mobile device, and then your mobile device will create multiple OTP codes. And then the installation guide of the Google Authenticator will ask several questions. You can just click yes, yes for everything, and then it will store a different file in your user's home directory. So that is why I'm asking not to run this as a different or sudo user. And then you need to go into SSH PAMD, and then you need to include these two lines into the bottom. And then on the SSH configuration, you need to change the challenge response to yes to enable the OTP, and then you need to restart the service. So once you do that, you can check whether this works. Most of the time it should not work, because we need to tell the SSH process to use multiple ways of authentication. So that is done by editing this particular file and adding this into the bottom. So here it says you can use public key You can use password. So the password public key is the same line, the same thing. First one, public key. This is the password, and then the keyboard interactive. Keyboard interactive means the OTP. So in this case, your public key will be checked, then your password will be checked, and your keyboard verification will be checked. And if you want to disable the password and just use the public key and the keyboard interactive, you can simply go back to that particular file and comment the line with this content. So there should be a line called at include common auth. You can comment out, then the password authentication will be removed. So this is for Ubuntu 20.04. So there will be little changes on other earlier versions, but you can Google them and see how to do that. So in this case, I'm in this case, I'm using Ubuntu 20.04. So I'll just show you how to log into this. So I'm just SSHing. Hope you can see my screen. So I'm trying to SSH, and then it didn't ask me a password, but it did ask something called verification code. So this verification codes comes in my mobile device. So the verification code I will enter, and then I am logged in. So if I if I do an ls again, ls -a, you can see there's a file created by the Google Authenticator. So this Google Authenticator file contains the details of my verification codes. And then on the on this file, you can see I have commented out the include common auth. Because of that, it doesn't ask me any password, but if I want, I can just include that as well. And then the two so keeping that screen there, I am going to reconnect from a different tab. So now it's asking me a password. So I need to enter my password, and then it asks for the verification. That I need to get it from the Authenticator software. Now I can log in to SSH. So in this way, we are using 3 authentication methods: the public key, password, and then the verification code. One other thing I need to show you, that if you use -v flag with the SSH from a Linux console, you will see all the communication debug between your client and your server. So here you can see the open SSH version, the configuration lines, the files that is being checked. Then it's authenticating to this IP on port 22 as Tilina, and then the host algorithms. So you can see SSH have sent a public key, and then it is being checked. So here you can see the message have been received and it has been accepted. Authentication, then they do the public key authentication, and then offering the public key that was saved, and then the server accepts the public key, then authentication success, but partially. Now you need to continue with the password and the keyboard interactive. So the password I need to enter, and then it asks for the verification code. And that is, so once I enter the password and the verification code, it says authentication succeeds, and then sends the other details, and then I can log into this system. So that is how the multi-factor authentication works with SSH. So why I am showing this to you is, it's better if to use multi-factor authentication, at least public key authentication for your different servers, because it will add a additional layer of security into your server. Otherwise, if somehow your password gets leaked, then anyone can log into your server. So in this case, you have multi-factors. You need to have your private key, you need to have your OTP code, and then you need to have your password. So any one of these can be leaked, but still you can't, anyone can't log into your server, because they need to have 3 factors to log in. So that is why we ask most of the administrators to do multi-factor authentication, at least for the important services. Things like servers, email, web servers, email servers, LMS, or even for web-based services, try to go with multi-factor authentication. Okay, so that is on SSH. I'm just quickly going through all the stuff because I'm running out of time. We only have 1 hour left. Then there's a tutorial on HTTPS. Again, how to create HTTPS on your servers. So this is the self-signed certificate. I hope almost everyone know how to do the Apache installation on web servers. And then this is the way you configure self-signed certificate. Self-signed means you don't send your certificate to a third-party CA, but you just create your public key and private key. So once someone wants to log in to your HTTPS system, they will verify against all the CAs for your public key. But since your public key doesn't have any CA, your user will be prompted saying, this is an untrusted certificate. Do you want to go further, or the connection will be dropped? So in newer browsers, like I guess even in Google Chrome, they don't give you the option to accept that exception. But in Firefox, you can simply put an exemption into the self-signed certificate and then log into the system. Then there are things like how to create the configuration files. But the main part that I want to highlight is, make sure you enable HTTPS for every service. So by now, all the browsers, they defaults to HTTPS. So try to go with HTTPS. And if you don't have the capability of buying a proper certificate, always try to go with Let's Encrypt and Let's Encrypt, because Let's Encrypt is free to use and you can always rely on that because it's already a trusted entity. So most of our websites, including the if you see this website where we put the tutorials, that is also using Let's Encrypt certificate. So at Learn, there are like hundreds of websites. Every website we are using Let's Encrypt if we want to do a private SSL certification. There are like self-signed certificate sites, but most of the time we'll be using Let's Encrypt if if we are running on HTTPS. Okay. So the installation of Let's Encrypt, you can go to their official website and follow the guidelines as per your operating system. I'm not going to put them on here because they tends to change time to time. So better to stick with the original website. It's easy. So it's actually, it's you just have to select whatever the software that you want to install and then the operating system. Then it will give you all the installation guides. You just have to run them in your console. So only thing with certbot is, so the software is called certbot. The certbot changes are like, if you want to run everything by certbot, just enter certbot and then the server type. But if you want to create only the certificates and then if you want to create the configuration by your own, then you can run cert only. So this won't affect any Apache configuration, but this will change the Apache configuration and then it will be completely automated. But for this, you need to have working DNS. So you need to have public IP connectivity. You need to have both HTTP and HTTPS enabled from the firewalls, and then make sure the HTTP configuration have the attribute server name with the proper DNS value, and then all the DNS values are assigned or deployed. Okay, so this IP is like this server doesn't have Apache installed yet. Let's see whether we can do it in a few minutes. Okay, so I created the web server on that particular IP that was like 113. Yeah, so this is the installed Apache, and then if I want to run certbot here, first I need to go to Apache configuration. Yeah, so the default file is like 000 default.conf. I'm going to get a copy of that. Then again, I'm going to create another file, secondhost.conf. I'll come into that in a later. So then I'm going to edit this file, and then I'm going to put a server name for this. Okay, I have a DNS called uprouse1.helena.tt.lk. Let's make it. Oh. One. And I have another host called so let's put it in a different folder. Okay, so A2 and site. Okay, so so in this case, the HTML folder is this, and then I'm creating this should work. Let's see. Okay, so I have created two files for this. So if I include this, you can see high one. So it again goes to so you can see the first URL and then the second URL as this. So it's high one and high two. So installing, I'm not sure how much time will it get. Let's see. Okay, then I'll install this. And then I'm going to run this. Since I'm running as root, I'm not going to use sudo. So once I run certbot, it will ask the email of the user. So for me, it's like this, and then it will ask me to accept the document for the first time. Then it will ask me whether I need to share my email with something else. I'm not going to say that yes, just no. And then it have automatically detected 2 domains. So these are the 2 domains. So I can select one particular domain, or I can simply keep it blank and then click enter. So if I click enter, keeping blank, then it will do the SSH generation, SSL generation for both of the domains. So yes, I need to do it for both. So I just click OK, and then it will do the verification of the domain. Yeah, now it has already deployed. Now you can see they have done the installation. So if I refresh this, now you can see the HTTPS enabled, and the connection says it's secure. So the same thing, if I refresh this, this is enabled. So you can see the certificate. So this is the certificate. So likewise, you can simply deploy HTTPS within minutes. So now you can see I just took like less than 15 minutes to do the whole thing. So likewise, you can enable HTTPS in any of your web server, but make sure you renew this during the time. So okay, so that is HTTPS, and make sure you enable HTTPS in all your websites. I have seen some of your websites using HTTPS with public CS, the commercial CS. That is fine. So if you have money to do that, then that is fine. But for other websites, also try to migrate those websites into HTTPS with these sort of free mechanisms, because now we are looking at encrypted network. So because of that, it's better if you can have all the encrypted stuff. Okay, then I'll go to the UFW part. UFW is the Ubuntu IP table software that makes things easy. So all the configuration are there. I just wanted to show you a small thing, this one. So UFW by default is disabled. You need to enable it. But before enabling it, make sure you allow SSH before enabling, and then once you do the enabler, you can write different rules. So in this case, I just want to focus one thing on the rules. So here you can see 2 rules written to allow TCP connections to port 22, that is SSH. So you can see the first rule is allowing TCP connection from a particular IPv4 host. So this is IPv4 host with /32. That means a single host. But if you have a network, you can increase the you can decrease the number of host subnets. And then to any port 22. The main other point is this IPv6. You can do the same thing for IPv6, but now it's going to be /128 IP address, the static IP address of the IPv6 device, and then /128. If you are going to allow it for a subnet, then it can be /64. So it depends on how you do. And once you see the status, you will see something like this. So I haven't enabled UFW status. Yeah, UFW is not enabled. So now it's enabled. So this is something that I have done. So you can see OpenSSH is enabled for V4 and V6 both, but for V6 I have enabled only port 80. So actually traffic coming from this particular IP will be allowed to enter into port 80. So if I now go there and do a refresh, on this website, you will see a timeout because now it's not connecting because of the firewall. I haven't enabled anything. Then there was a question regarding HTTP2 and HTTPS. Yes, HTTP2, you should enable HTTP2 as well as HTTP3 if your browser supports, because all the new browsers, they support HTTP2 and HTTP3. So if your server end supports HTTP2 and HTTP3, then make use of it, because it will provide a fast deployment of your web server to the client, especially with HTTP3. So if you can go with HTTP3, then definitely enable that. Then it will support. It will reduce the latency between your website and your browser. That can be done on from the Apache configuration, but this is not related to security, so it is only for the latency and the speed of the website. Okay, then yeah, then I'll quickly go to the other presentation. Okay, now I'm messing with the time. Okay, so this is some of my slides that I used to teach security for some students. So I'll take some of the slides about the firewalling and the IPS because there's a difference between the firewall and then the IDS systems. What firewall do is it just prevent based on the predefined rules, but NDS what it or network IDS what it will be doing is it will be detecting based on different rules and different anomaly patterns. So NPS is like the IDS plus firewalls where you define rules. If something is detected at some level, then block that. So this is the big picture thing. So firewall normally works at the layer 3 or maybe layer 4, but new firewalls are there, which is called NGFW, which works on the layer 7. But in case of NIDS, NIPS, there are most of the NIDSs working on the layer 7. And even with the custom data or the actual data. Then, yeah, I will share these details with you. So benefits of firewalls and shortcomings of firewalls. What are the things that you should not do with firewalls and what are the things you should do with firewalls. The default rule, most of the time firewalls have the default rule as deny. So if it's not allowed, then you are not allowed. Basically, it's denying everything. Then what is ingress filtering and egress filtering? Whether are you filtering something that comes to your interface or something that goes out from you. So protecting something, protecting a web server or protecting a SSH server can be the egress filtering, and dropping maybe YouTube or maybe dropping some particular website based on firewall can be the egress filtering. Then there are different types of firewalls, the packet filters, the basic thing, and then the stateful inspection, and then proxy. So next generation firewalls. Okay, so that is something that I just wanted to quickly go, and then I will go to the actual slides. Yeah, so I agree. There are a lot of content for 4 hours, so I'll try to quickly go through this as well. So during the half an hour period. So intrusion detection is like there could be an intruder even if you have security practices. So let's say you have a firewall. Let's say you have a lot of other security mechanisms like strong passwords, password rotation, everything is there, but still there can be something that happens in your network. So that is where we need to do the security intrusion detection. So can you tell me whether are you already using some sort of an IPS device or next? Okay. What else? Anyone else?
No,
Hmm.
no ideas.
How about firewalls? Mhm. Yeah, so OSSEC and PFSense are kind of open source applications that provide different things. So OSSEC is kind of an IDS, and then PFSense is kind of a firewall altogether. Ativo, that I'm not aware of. What is Ativo? Oh, okay. Yeah. So yeah, so there are a lot of other applications. So most of the time people don't try to go into okay, so Ativo equals detection and deception. So is it free? So the intrusion detection is when you want to detect the unknown things. So the capabilities of the IDS can be the detection of attacks and maybe the detection of infected files, strange behavior of network traffic, maybe recognition of statistical anomalies. So those things are depend on the capacity or the capability of your IDS. So things like Snort, they can be they can be used to develop different detection patterns. Again, even OSSEC OSSEC plus actually can be used to do the AI based pattern recognition. So those things are there to help you, and let's see why we need to use them. So when we look at the IDS, they can't do things that a firewall does. So it can't check the authentication. It can't do different authentication identification methods. It might not investigate. It might not check all the attacks without human intervention. And then it can't check your security policy. It can't encrypt data, or it can't read data unless you do the lawful interception of the encrypted data. Then they can't check things like IP spoofing. So they can't do those things. That is why most of the time people go for next gen firewalls. Unfortunately, I can't. I'm not in a position to recommend any next gen firewalls for you, because most of the next gen firewalls are like commercial firewalls. Only thing I can recommend is using pfSense and things like OSSEC if you want a different IDS platform. But if you use pfSense, you can use stuff like Snort already installed in the pfSense. So when you look at the NGFWs or next gen firewalls, most of them are commercial. So it depends on your budget. If you have the budgetary allocations for having an next gen firewall, please go with next gen firewall. So I'm not saying you should go for open source firewalls because it's easy. If you have budget, go for good next gen firewall. So it should be a next gen firewall which supports layer 7 and above data. So the things with IDS will be, there will be different false positives, there will be different false negatives. So you need to think about the output or the alerts of the IDS. So whether this is actually a true alert or whether this is a false alert based on something. So the false positives, false negatives will be there. So make sure you know that. Make sure you check that before acting on something. Then when looking at IDS, there will be two types of IDSs, signature based and anomaly based. So most of the time, things like Snort will work on signature based level, and things like OSSEC plus it will work on anomaly based. So the difference between these two is like signature based, you have to, in signature based, you have to make sure, create the signatures on how to detect things, but anomaly based detection, they will do the statistical analysis of the content, and then it will create alerts based on the behavior of the data. So the difference between detection and prevention is detection, it just do only the detection, but if it's a IPS, if it maintains IPS functionality, then it will prevent the functionality as well. So the thing here is you need to check whether you can apply an IPS in your network, or else you can always use antivirus softwares that have the IPS capability. So most of the modern antivirus softwares, commercial antivirus softwares, they have this facility, the inbuilt IPS. So it will be a host-based IPS. Okay, so which should you deploy? When you are deploying an IPS IDS device, you need to think about your network speed. If you are running on a 100M network, then a small IDS device might be sufficient. But if you are running on high speeds like several gigabytes, then check the specifications of your IPS IDS and check what is the highest capable bandwidth that they can cater. Otherwise, your IPS IDS will become a big bottleneck of your network. So make sure you deploy an IPS IDS. So it doesn't matter whether it's open source software, whether it's a commercial software, whether it's a commercial device, whether it's not, whether it's some commercial product, make sure the specifications allow you to cater the whole bandwidth you have. So this is specifically for the high speed networks. And then the updates, how frequent you will see the updates for signatures and rules. If your product doesn't have frequent updates, don't go for that. If they ask extra cost for updates, don't go for that. So your device should have frequent updates, but at low cost, because there are a lot of products in the market. So almost all work as same except for the rule base. So basically you can use something like Snort or OSSEC in your network free of charge without going into a commercial product. Only cost will be purchasing the hardware. So a small server with several RAMs, several gigabytes of RAM will be sufficient. Okay, so I have kept few slides on Snort, but I'm not going to go into details of Snort. So Snort is just an open source IDS where you can simply download it freely and then use it in your system. It supports gigabits of speed. So we have tested gigabits of speed with Snort. You can run Snort in two ways, either the IDS method or IPS method. If it's running on IDS, you can run it on a span port. Span port means a mirrored port. You can mirror the traffic that is going out or coming in at your border, and then put the mirror into the IDS. Make sure your physical server have at least two connections, one for the span port or the mirrored port, and then the other for the management. If you use the same port for the management, then you will see a lot of errors in the detection, because your management traffic will also be monitored as a mirrored content. So make sure it have at least two interfaces, one for management, one for the span or the mirror ports. Then you can use these devices inline if you are running it as a IPS. So this IPS can be on behind a firewall or as well as in front of a firewall. So it depends on your network setup. Most of the time people use the system router, firewall, and then the IPS. But still you can use router, IPS, and firewall. So this is something about the Snort rules. I'm not going to go into details, but normally Snort rules have two parts, that is the header part and the option part. The header part contains the things like the what you need to do, the action, then the traffic types, destination sources, port numbers, those things. And then the rule options, they contain the details of what you need to detect. So if there are different patterns, if there are if you want to detect a particular pattern in the data, then that will be a rule option. You can install Snort as an IPS with pfSense. This is kind of a traditional network setup where you can install IDS or a firewall. So in this case, this can be a pfSense running an IPS or an IDS, or this can be a commercial firewall running all the things. So traditionally, most of the time people use it in between the border route and any other core network. The drawback of this is if you are running something like this, then the whole traffic going out will be checked here, but that means then you need to have a proper firewall or IDS, otherwise you will be seeing a bottleneck at this location. Then because of the RNE networks, there's something called science DMS, where we put the big data things in a different location with the high speed connectivity, and we separate the other network from those things. So the big data or the high capacity network will have a different connection, and the rest of the network will be changed. So if I go to the image, so this is that approach where you separate your servers in a different location. So it is not directly connected to your border router. It's not directly connected to the internet, but it connects to your core network in a separate location. So this location can have high data capacities, maybe high data from here to these locations, but a small data capacity, network capacity from here. So again, you can put a IPS or IDS system spanned or mirrored on your core router. So earlier in here, you can see the same thing. Again, you can span different links if you want to see those things. So why we are saying like this is, if you put a firewall or a IPS device or a mechanism in front of your core network to the border, at some point it can become a bottleneck where you try to increase your bandwidth, but ultimately you end up getting the same output for the network because of the device that is in the middle. So we have seen the same effect with some devices like where they increase this link into like 1G, but then they use 100M links for the distribution. So the users in the bottom, they will get maximum 100M from this 1G link because these links doesn't support 1G. So make sure those kind of bottlenecks are not there when you are putting something into your network. So it will happen, it will be the same for firewalls. If your firewall doesn't support 1G but it only supports 500M, don't put that firewall or that IPS in your 1G network. Sometimes your firewall might have 10G ports, but it doesn't mean it supports 10G networks. It will support 10G ports, but it doesn't support 10G capacity. So make sure you read all the specifications of your network, of your firewalling device before going into purchasing something based on the recommendations, especially from different vendors. So we have seen a lot of issues with different parties, especially when they come into the university and then the vendors, they propose different solutions, fancy solutions, but they might not be the perfect match for your environment. They will say they have firewall, they have IPS, they have HTTPS inspection, they have DLP, or a lot of things. So just check whether they are needed in your environment. So a single firewall and a IPS might be more than enough for your RNE network. You don't need high-end stuff. So don't try to create a business for them, but to make it useful for your institute and save the money. So that's why we are pushing most of you to the open source side. And the best way is to try, if you are not using firewalls, if you are not using any IDS, please go ahead with pfSense. I will share some of the pfSense tutorials that we were using for Learn community. You can follow the same and try out them. in Learn community, there are a lot of institutes where they use pfSense. So even big universities, they sometimes use pfSense for some purposes. So try to do that. And if you really need a commercial support, then go for commercial product. Then the last thing, I guess, is whatever you deploy, whatever you put in your system, don't think your system is 100% secure. So the defenses will not be perfect. There will be different patches which are not applied. There will be different softwares, different IPS, IDS, antivirus solutions that doesn't have up-to-date signatures. There will be a lot of 0 days. There will be different infected USBs, even insider misbehaviors. So your network is not 100% secure. So please keep that in your mind when you deploy these things. Then I was planning to discuss few hardening tips on CMS, but since it's like almost 5 more minutes, what I were planning to do with you is asking you to install a common CMS of your preference. I'm not going to provide you any guideline. I'm not going to provide you how to install, because you are already doing that in most of your cases. So put a VM and then install a common CMS as per your understanding, and try to harden the installation with whatever the things that I already told. Use secure SSH, use HTTPS, try to do the firewalling like UFW, and then from the CMS side, you can do a Google search and see what are the basic stuff that you should do to secure that particular CMS. For example, if it's a WordPress, then the WordPress tutorial, WordPress documentation, they provide basic security steps that you should do. Make sure you do that. And then even for Joomla or things like Drupal, try to find the standard or the basics of the security for those particular CMS and then apply them. And keep it for the next day, because next day we will be or the third day. So third day means not tomorrow. So actually tomorrow and the day after I am not available. Because of that, we'll be doing the third day on the 10th or the Friday. So Friday we'll be looking at vulnerability scanning. So I'm trying to minimize the theoretical part for the vulnerability scan and then do some hands-on on vulnerability scanning, and then do some analysis using Wireshark. So most probably the day 3 will be completely a hands-on, and before that, make sure you install that CMS as per your understanding and as per the things that you are doing at the moment, so that we can do a vulnerability scan and see whether there are any issues in your installation. Later on, you can apply those whatever the findings to your actual systems and secure your system. So that is the actual plan. First, you get to know what you are doing, and then test that with testing environment. So this VM will be a testing environment, and then apply that in your actual scenario. So that is the plan we are going to do. Okay, any questions? So I was like talking for 4 hours. Are there any questions? Okay, so yesterday we discussed on creating policies. So I shared you a document. Try to complete it. Try to complete that document. What you have to do is first set up few reference points like the URLs that I asked to list, and then there were already some do's and don'ts. Try to get the same thing, and then after the workshop we will come up with the plan in creating a common guideline so that we can have the common policy if someone is not having a policy, so they can just use that policy and deploy it in their institute. So try to complete it by next 2 days. Again, do the VM installation and the CMS installation for the next 2 days, and we will check it on Friday. Then there's a question asking what is the difference between the paid certificate and the free version, whether they have any extra security. Actually, there's no extra security contained in the paid certificates. Only thing is, those paid certificates might have different levels of verifying you. For example, if you have seen the banking websites, those banking websites have mostly shown their name on that padlock, the HTTPS padlock. So providing the name on the padlock is an additional thing that will cost you some amount. So that is only provided by the commercial entities. So Let's Encrypt, they just provide you the basic HTTPS, but it doesn't mean there's a hole in the HTTPS. HTTPS will be just HTTPS, but it will be only the authority or the identification of who you are. So if you want your users to identify your website as it from a particular institute, so for a bank, for a financial entity, that is more important because people need to go into their financial websites, and then they want to enter their account, and then they want to do their financial things. But in an academic environment, do you really need that? So that is a question that you should ask from the management, whether they need something like that. So it's kind of an additional layer of information, not the security. It doesn't have much. So the theoretically or from the protocol wise, there's no difference. So because of that, you need to just you can simply go with the free versions if you are just securing an educational website. But if it's a financial website, if it's a highly secure website which needs their users to know who you are, then Yeah, go for paid certificate because paid certificates will give you the name and those other details. So actually there's no difference from the security side. Okay, any other questions? If not, I can stop. I will stop the workshop for today, and thank you for being with me for these 4 hours. So again, we will meet on Friday, and today's recording and today's slides will be uploaded to the website in few hours time. Once they are ready, so especially this Zoom recording takes some time, and then I will upload it into the website. Okay, then thank you everyone, and see you all tomorrow. Not tomorrow, Friday. Okay, see you. Bye.